So now we're going to take our mapping and we're going to turn it into actually solving. So the first thing I want to do is right here off to the side is just review our toolbox, okay, like we've done so far. The very first thing we learned was mole ratios, which gets us from moles of one chemical to moles of another. The second thing we learned was our molar mass, which gets us from moles of a chemical to grams of that same chemical. And the third thing is molar volume, which gets us from moles of a chemical to liters of that same gas. Remember, it has to be a gas at STP. So before I start solving this, I'm going to identify all of my molar masses, find all of my molar masses first. So that way when I need them, I already have them ready and I don't have to pause to stop anything, okay? Okay, so now that I've got my toolbox written, I'm going to identify my molar masses in order to actually start to solve. So N2, the average atomic mass of nitrogen on the periodic table times 2 would be 28.02 grams per mole. Hydrogen is 1.01, but there are 2 of them in H2, so it's going to be 2.02 grams per mole. And then in H3, we've got 14.01 plus the 3.03 from hydrogen, which is 17.04 grams per mole. So now I have all of my molar masses, so when I'm ready to solve, I've already got them ready, and I don't have to pause and try to solve those first, okay? So looking at this question, how many grams of NH3 are produced if 25.5 grams of N2 are used? Okay, what are you starting with? Perfect, and what are we gonna find? Perfect, grams of NH3. Okay, so I know I've got grams and liters on the roof, moles on the street. I am gonna map this out. We've got all of our houses. So I'm starting with 25.5 grams of N2. And I wanna know, well, how many grams of NH3 does that make? All right, so if I'm mapping this out, my first step is going to be to go from grams down to mole street, so moles of N2. From here, I'm going to walk on mole street over to moles of NH3. And the last thing is I'm going to basically climb back up to that roof to get to grams of NH3. So I've got 3 steps here. Grams to moles, and then moles back to grams, but of the other chemical. So I'm going to solve this stepwise, starting with the very first one. So our given, I'm going to look at this blue arrow over here first. So our given is 25.5 grams of N2. I've got my train track. The first step is to take the grams of N2 and transfer that down so your units cancel. Okay, now to actually solve, the mapping is a map. Wherever the arrow is pointing, it's telling you what to do next. It's telling you what unit to solve next. So it's pointing to moles of N2, meaning that my first conversion is moles of N2. And looking at our toolbox, what do we have that gets us between grams and moles? The molar mass, perfect. So I've already solved for all of them. So what number would be on the top? 1 over what? 28.02 grams of N2. Grams of N2 cancel, and now we're going to divide. 25.5 divided by 28.02. Put that in your calculator. When you get an answer, hold your calculator in the air. All right, brilliant. What's the answer for this one? 0.91 mole of N2. Okay, this first arrow now, I'm done. I just did that step, so I'm going to cross it out. I'm done. Okay, so now our units are in moles of N2. What is the new given? The thing we just solved for, right? So this now is our new given. So when I am doing the second step, I'm going to use the thing I just solved for, 0.91 mole of N2. I'm going to set up a train track. The mole of N2 drops down, so it will cancel. And if I look at the map I made, what unit am I trying to get to in the second step? Mole NH3, so that's going to go on the top. Looking at the toolbox, what do we have that connects moles of one thing with moles of another? So what number goes on the top? 2 over 1, and those numbers come from the coefficients of the balanced reaction. So mole N2 and mole N2 cancel. So 0.91 times 2. And that also means I'm done with this second arrow. So what is this answer? 0.91 times 2. 1.82 what? Okay, well, we're still not done though, right? Because I saw one more arrow to go. And what's the new given? Perfect. So 1.82 mole NH3 is the new given. And I'm looking at my last arrow. So my mole of NH3 is going to cancel on the bottom. And what am I trying to find? Grams NH3, because that's what the problem asked me for. So that goes on the top. Looking at the toolbox, what do we have that connects grams and moles? Molar mass. So what number goes on the top? 17.04 over 1. Mole NH3 cancel, so we're going to multiply. I'm also done with my last arrow, so I'm going to cross it out. When you have an answer, hold your calculator in the air. Okay, what is the answer? 31.01 what? There it is. Okay, so here's what this means, that theoretically, if I run this experiment starting with 25.5 grams of N2, at the end, I should get about 31 grams of NH3. Okay, that's what it means. It's things I can actually measure. Now, there's an opportunity here for a whole lot of rounding errors, right? Because I round here, and then I round here, okay? So the way that we can do this is just set them all up at one time, like set our entire problem up, and then put this in our calculator one time, so we don't have any rounding errors, okay? So we don't have to worry about that at all. It's gonna give you a more accurate answer, okay? And the way that we can do this is say, all right, well, instead of stopping to solve each time, I'm just gonna put all of my ratios together and do it all at once. All right, so if I'm gonna redo this problem, but doing this as one train track, okay? So let's pretend like we're starting it over. I'm starting with 25.5 grams of N2. 25.5 grams of N2. In my first step, with my first arrow, I went to moles of N2. So my first step of my train track is also going to moles of N2. And I know I need grams of N2 on the bottom, so it cancels. This, what I've got right here, is the same as what I did up here. It's the same, because it's the same process. It's the same ratios that we're gonna need. So I'm gonna do 1 mole of N2 over 28.02 grams of N2. So just like before, grams of N2 cancel with grams of N2. But instead of solving to get this, to then plug it in, I'm just gonna keep going. Okay, I'm just gonna keep going and then put everything in my calculator at one time. So the next part of my map tells me to use the mole ratio to change my chemicals. So moles of NH3, moles of N2. I'm gonna use the coefficients of the balanced reaction. So that would be 2 over 1. Mole of N2 cancels with mole of N2. That's what this step is right here. I just did that next instead of solving. Okay, well the last step, the last arrow, is telling me to get to grams. So I know I'm going to need grams of NH3 on the top. Moles of NH3 on the bottom are going to cancel. So I'm going to use the molar mass the same way I did before. 17.04 over 1. Mole NH3, mole NH3. So it's like I just didn't solve this part, and I have my given, and then I have my first ratio, my second ratio, and my third ratio all in one. Okay, now the tricky part, or to make sure we're doing this right, is how to put it in your calculator. You can just multiply all the way across on the top. 25.5 times 1 times 2 times 17.04 divided by 28.02 divided by 1 divided by 1. Now I know when you multiply and divide by 1 it doesn't do anything, right? But these could be numbers. Yeah, this could be a number. So when you have two numbers in the denominator that you need to divide by, hit the divide button twice. A lot of students will hit divided by this and then multiply by that. Your calculator will follow order of operations. So if you don't have it in parentheses as a denominator, it will multiply your answer by that number instead of dividing, okay? So in your calculator, just hit the divide button twice. So practice putting this in your calculator all at once. 25.5 times 2 times 17.04 divided by 28.02. And when you get an answer, hold your calculator in the air. Okay, what's the answer?
31.
Oh, hey, 31.01. Isn't it the same answer? But now we only have to do it one time. Okay? So this is what's called a three-step stoichiometry problem. All right, let's look at number 2. Slide our paper up and look at number 2. So we're going to do this using the three-step problem. Instead of solving each one individually, we're just going to add our tracks together, and we're going to use our map to help us out. How many grams of hydrogen are needed if 16.75 grams of nitrogen react? So I'm starting with 16.75 grams of nitrogen, and I'm trying to find grams of hydrogen. All right, well, I'm going to map this out so we really clearly know where we're going. Grams and liters on the roof, moles are on the street. I'm starting with 16.75 grams of nitrogen, and I'm trying to find grams of hydrogen. So like I've done before, I can't roof jump, so my first step is to go to mole street, so moles of N2. My second step would be to walk over to mole of hydrogen. And my third step would be to find grams of hydrogen. So each one of those is a step. All right, so let's set up our given just like we've done before. 16.75 grams of nitrogen into. It's a long train track. I'm going to copy down my grams of nitrogen because I know I still need those to cancel. Now if I look at my first arrow, this is telling me the first conversion. Wherever I'm pointing to is telling me the units that I need for that step. So I need the moles of nitrogen for this step. Now if I look at my toolbox that I wrote earlier, the only thing I have that gets me between moles and grams is molar mass. So I'd have 1 mole of N2 over 28.02 grams of N2. Grams and 2 cancel, which means I'm done with this first step. So I'm going to cross out that first arrow because I'm done with it. I've changed my units. And instead of solving right here, I'm just going to keep going. And I'm going to solve at the end. Okay, now I'm on the second step. So I'm going to copy down moles of N2 because I'm going to need that to cancel. And this time I'm looking for moles of H2. That's where my arrow leads. That's the chemical that I want. I know looking at my, bless you, I know looking at my toolbox, the mole ratio is how I get between chemicals, and those come from the coefficients of the balance reaction. So 3 moles of H2 over 1 mole of N2, bless you. Mole N2 cancels with mole N2, which means I'm done with the second arrow. Done, cross it out. Last arrow. Well, I know my mole H2 has to cancel, so I'm going to put that on the bottom. And what are we trying to find? The last unit. Grams of H2. So that's going to go on the top. And I know that the only thing that gets me between grams and moles is molar mass. So what number would go on the top? 2.02 over 1. Mole H2 cancels with mole H2. I'm done with this last arrow. So I cross it out, which means I can solve. 16.75 times 1 times 3 times 2.02 divided by 28.02 divided by 1 divided by 1. Practice putting it in your calculator. And when you get an answer, hold your calculator in the air. Okay, what's the answer? 3.62 what? Of hydrogen. There it is. Okay, so why don't you try the next one on your own, and then we're going to go over it. Okay, so you had a chance to try it on your own, so let's do it together. How many liters of hydrogen are needed to make 432 grams of ammonia? So I'm starting with what? 432 grams of ammonia. If you didn't know which one was ammonia, it's just like process of elimination, right? You know nitrogen, you know hydrogen, so the only one left is NH3. And what are you trying to find? Liters of hydrogen. So I'm going to map it out, just so we all know where they're coming from. Grams and liters on the roof, molar on the street. I'm starting with 432 grams NH3, and I'm trying to find liters of hydrogen. So my first step is going to be going down to mole street, so mole NH3. Okay, where do I go from here? What's the second step? Mole H2. And what's the third? Liters of H2. Okay, so let's set up a train track. 432 grams NH3. I know that I'm going to copy down my grams NH3 because I need it to cancel. But what's going to be on the top? Moles of NH3, because that's what I'm looking for first. I have to turn it into the mole. So if I look at my toolbox, what am I going to use to get me there? Molar mass. So what number goes on the top? Over 17.04. Grams NH3, grams NH3 cancel. I'm done with this first arrow, so I cross it out. Okay, second one, I'm going to drop my units down so they cancel. What am I trying to get to? What's the arrow pointing to? Moles of H2. So I know I use the mole ratio to get from moles to moles. So what's the numbers on the top? 3 over 2. Mole NH3, mole NH3 cancel. I'm done with the second arrow. Okay, third arrow, almost done. I'm going to drop my mole H2 down. And what am I trying to find? What's going to go on the top? Liters of H2. And what do we have that gets us between moles and liters? 22.4 over 1, assuming STP. We're going to assume STP here. Okay. Mole H2 cancels with mole H2. I'm done with this arrow, so now I can solve. So when you put this in your calculator, 432 times 1 times 3 times 22.4 divided by, hit the divide button, 17.04 divided by 2. Hit the divide button again. Just hit it again. Okay? Remember, your calculator will follow order of operations. It will do what you tell it to do. Okay? So when you put all this in your calculator, what do you get as an answer? 851.83 cheeseburgers. Liters of H2. There it is. Okay?